Okay, quick video on the dot product. So we can do a dot product between two vectors using this equation. So here's our dot product. So vector A dot vector B is equal to the magnitude of vector A times the magnitude of vector B times cos theta. So here's vector A. In this first question here, it's pretty straightforward. I tell you the magnitude of each vector, and the angle in between the vectors is 40. So you're just plugging it into the formula. So 20 times 30 times cos 40. And you plug that in and you get 20 times 30 times cos 40. 459.6 for your dot product. And it's important to note that when you do the dot product between two vectors, the answer that you're getting is a scalar quantity. So there is no direction, it's just one number, a scalar. Okay. Let's try, let's try a question like this next one, vector r plus vector s dot vector r minus vector s. So this is kind of like using our properties of vectors to simplify something. Okay, so I'm just going to move that up here. So using my distributive property, I know I can do this kind of thing to expand. So I'm going to do vector r dot vector r. So I got vector r dot vector r. Then my next one, vector r dot vector negative s. So that'll be minus vector r dot vector s. Then this one's going to be plus vector s dot vector r. And then finally positive vector s dot negative vector s. So it's going to be negative vector s dot vector s. So I just expanded each one, started with the first one, multiplied it by the second, not multiplied it, but did the dot product, then the next one, dot product. Okay, so some things I can simplify. So I know that r dot s is actually the same as s dot r because I proved that. I didn't prove it, but I told you that. So if I rewrite this as vector r dot vector s, so if I just rewrite it, if you notice, I have negative r dot s, positive r dot s. So you know what? These guys are going to cancel out because say the dot product between r and s is 10. If I have negative 10 plus 10, that's going to cancel out. So in fact, all I'm left with is vector r dot vector r minus vector s dot vector s. And I can actually simplify those slightly. So if you think about our example up here, where we did a dot b. Okay, let's say we did a dot a. Let's see what happens when we do the dot product between two of the same vectors. So if I just had vector a, okay, so now my equation becomes magnitude of a times cos theta. Okay, so the magnitude of a is 20, so 20 times 20. And cos, well, what is theta? What's the angle between vector a and vector a? I would say 0. There's nothing between them, they're the same vector. And I know the cosine of 0 is actually just equal to 1. So really what my answer ends up being is just 20 times 20 times 1. And 20 is the magnitude of vector A. So we can also say that when you do the dot product of two of the identical vectors, what you end up getting is the magnitude of those vectors squared. Because the magnitude of vector A is 20, and I've got 20 times 20. So when I do the dot product of a dot a, I ended up with the magnitude of a squared is all I get. So I could actually write this as the magnitude of r squared. And like that's pretty much it. I just simplified this, but I don't know what vector r or s is, so I would just leave it like that. Okay, next question. So I've got two algebraic vectors in three space, and I want to find the dot product. So if you recall the dot product, we just multiply the x coordinates together, then add it to the product of the y coordinates, and then add it to the product of the z coordinates. So if I want to do u dot v, I'm just producing a scalar quantity, not a vector. So my equation will just be 2 times 3 plus negative 1 times 5 plus 4 times 1. So 2 times 3 is 6 minus 5 plus 4. So I end up with 5 as my final answer. Okay. Here's an example of work. So I don't know. I took this from a homework question. So there's somebody in a wheelchair race, and they're racing up a 300-meter hill. So they're racing up a hill with a constant force of 500 newtons applied at an angle of 30 degrees to the surface of the hill. So that's 500 newtons. And they're racing up a 300-meter hill. So this hill is 300 meters. So the definition of work, if you recall, work is equal to the magnitude of, well, okay, pretty much F dot S here. So what work is equal to is the magnitude of the force. Actually, let's do this again. Okay, so work is equal to the magnitude of the displacement. So pretty much how far you're traveling. So that's 300 meters. And it's multiplied by the force that you're doing, but in the direction of the displacement along the surface of the hill or whatever. So this person's doing 500 newtons, but since that's at an angle of 30, we kind of want to know, well, what will that be kind of projected onto this vector? So we're kind of looking for like the x component of that. Like what's this value here? And then we'll multiply it by 300. So it's pretty much the dot product. Because this value x here would end up being 500 cos 30 times 300. So really that's the dot product. So it's just the displacement that they're traveling, and then whatever the force that they're doing, we're looking for like the x component of that, because we want the magnitude along the surface of the hill, which is 500 cos 30. Or we're just looking at the dot products between these two vectors here. Or Newton meters, also known as joules. So that's how much work this person's doing in their wheelchair. And one last thing about the dot product is its formula is super handy for finding the angle between two vectors, which is handy. So if we have two vectors, and I could give those, I could give you the magnitudes of them, or I could tell you their Cartesian vectors. These are clearly not. I just made them up. So anyways, and I might want to know what the angle between those vectors is. So it's kind of handy to, I'll just show you how it's done, but it's kind of handy to use the dot product for that. So A dot B is equal to the magnitude of A times the magnitude of B times cos theta. So if we're looking for the angle between two vectors, if we isolate cos theta, that's and then I can just do inverse cos to solve for that. So to find the dot product of B, I can just use the two formulas. So 1 times 2 plus 3 times 1 plus 2 times 4. Figure that out. To get the magnitude of each vector, I can do like Pythagorean theorem thing and find the magnitude of A, find the magnitude of B, and then I can use this formula to help me figure out angles between vectors. Another important thing about dot product is just looking at when you have perpendicular ones. So when solving crazy problems, it's nice to know these properties of vectors. So if I have two vectors that are perpendicular to each other, then I should know based on the formula, based on this formula right here, my definition of the dot product, if this angle here is 90, so if the two vectors are perpendicular or orthogonal to each other, I know right away cos 90 is equal to 0, and anything times 0 equals 0. So I know the dot product between two perpendicular vectors is 0.